Hello everyone. So today we will continue with statistics in industry and commerce, and we will cover today to understand the use of estimations and confidence intervals in business contexts. In this session, we will cover the concept of sampling distributions and confidence intervals, outlining business contexts where confidence intervals can be used, explaining how to determine the confidence level for a mean using the T distribution for small samples, and explain how to determine the confidence interval for a proportion, and finally, how to determine the confidence interval of a given size for a stated probability. So first we begin with explaining the concept of sampling distributions and confidence intervals. So a sampling distribution, it basically refers to the distribution of a statistic, which is such as the mean or the proportion, when calculated from multiple random samples drawn from the same population. So it provides insights into the different variability and the characteristics of that statistics. So the key point about sampling distributions include random sampling. This assumes that the samples are drawn randomly from the population, meaning that each member of the population has an equal and non-zero chance of being selected. Then we have the central limit theorem. So the central limit theorem, this concept, it is related to sampling distributions. So it states that for a sufficiently large sample size, the sampling distribution of the sample mean will be approximately normally distributed. So what this means is that the sample is assumed to follow a normal distribution, irrespective of the shape of the population distribution. So this theorem is the foundational theorem for many statistical analysis. So next we look into the variability. So this aspect of sample distribution is that it shows how the characteristics of the sample, they vary across samples. So it provides insights into the spread or variability of the statistic. So next we look into the confidence intervals. So a confidence interval is a range of values that is calculated from sample data and is used to estimate the range within a population parameter, such as population mean or proportion. So it is basically the range which is used to determine where the results are actually valid. And so it provides a measure of the precision and uncertainty associated with the sample estimates. So some of the key points about confidence intervals is that how much of a confidence level you are willing to take with respect to a sample. So what it means that it is typically expressed as a percentage. For example, it could be like 99%, it could be 100%, 95%. So a 95% confidence interval, it basically means that you are willing to allow outliers of to the extent of 5%. A confidence interval, it also consists of a point estimate. So which means the sample mean or population and a margin of error. So the margin of error, it quantifies the range of values. A margin of error, it quantifies the range of values around the point estimate. So the interpretation of margin of error is that a 95% confidence interval for the population mean might be stated as we are 95% confident that a true population mean falls within this interval. So next we look into wider intervals. So higher confidence levels result in wider confidence intervals because they require a greater degree of certainty that a parameter falls within the interval. So in summary, sample distributions, they help us to understand the behavior of statistics. when calculated from different samples. So it basically sees how the different samples are distributed and how what is the level of confidence that you can draw upon for using the different samples for conducting the test statistics. So these concepts are useful for making statistical inferences. For example, if you are conducting a correlation test or if you are conducting a multiple regression test, so how valid are the results? So these are the estimates that you can get from these sample, these characteristics such as confidence intervals. So next we look into the business context where confidence intervals can be used. So basically, why we are studying these characteristics of statistics is that we can actually apply these in industrial context. So some of the key business context where confidence intervals are commonly used is, one of them is market research. So in market research, a confidence interval is used to estimate the average customer satisfaction score for a product or service. Then it determines the mean response time for customer support inquiries. And another example is calculating the confidence interval for a market share of a product within a specific region. So the next example is sales and revenue forecasting. So confidence interval, it is used to estimate the mean sales revenue for a new product launch. So when you're conducting a survey, so you can get the different results from different samples. So you can estimate the mean sales revenue for a product launch with a given confidence interval. Then predicting the total revenue for the upcoming fiscal year. So again, this statistics criteria is used for predicting the revenues for the upcoming year. And then determining the average monthly sales for a retail store. So this is again an example where you can use confidence interval for sales and forecasting. Then in financial analysis, the concept of confidence interval is used to estimate the return on investment for a portfolio of stocks. So how confidently you can say that you are going to generate this type of return. For example, if you are going to beat the index such as FTSE 100 or S&P. So that is where confidence intervals are used. Then calculating the confidence interval for a net profit margin of a company. So that is again an area where confidence interval can be used. And then assessing the uncertainty in the projected cash flows for a business expansion project. So for example, if a company is undertaking a new investment and it is a new area of business, so how uncertain are cash flows and whether extended periods of negative cash flow can lead to profitability later on, or whether you can sustain the business. Then we have quality control and manufacturing. So again, the concept of confidence interval is used for estimating the mean product defect rate in a manufacturing process. And then determining the confidence level for a mean product weight in a production line. For example, if a company has say 20 or 30 products, so what is the mean product weight and how much revenue it is going to fetch? Then assessing the average downtime in a factory. So it is done on a quarterly basis, monthly basis, or yearly basis. Then you have confidence intervals in business context. So here again, another example is where assessing the customer satisfaction and feedback. So here you can use the confidence interval for mean customer rating for hotels amenities and calculating confidence interval for the proportion of satisfied customers. And then it could be like determining the mean wait time at service for a restaurant. Then in human resource and workforce management, confidence, the confidence intervals, it can be used for estimating the mean employee turnover rate in the company. For example, it can be used for assessing the attrition rate in the company. Then it can be used for calculating the confidence interval for average employee satisfaction score. And then assessing uncertainty in average hours worked per week by employees. And finally, in risk management, this confidence interval is used in estimating the mean loss in a portfolio of insurance policies. So it cannot be only insurance policy. For example, in a portfolio comprising of stocks, bonds, and various other asset classes, you can estimate a mean loss in a portfolio with a certain confidence level. Then you can calculate the confidence interval for the expected claim amount in a given period, and then assessing the uncertainty in the project default rate for a loan portfolio. So then we have supply chain and inventory management. So in the supply chain and inventory management, the parameter of confidence interval can be used for estimating the mean lead time for delivery of raw materials, then determining the confidence interval for average demand of a product. And then it can also be used for assessing the uncertainty in the reorder point for inventory replenishment. Then marketing and advertising. So confidence interval, it can be used for estimating the mean click-through rate, which is CTR. So this is an important parameter for online advertising campaign. Then calculating the confidence interval for conversion rate of a marketing funnel. Then determining the average return on investment for a digital marketing campaign. So again, confidence interval, it can be used for these parameters in marketing and advertising. Then we have healthcare and pharmaceutical research. So in healthcare and pharmaceutical research, confidence intervals can be used for estimating the mean effectiveness of a new drug in clinical trials. And then it can also be used for calculating the confidence interval for average patient recovery time. So finally, to conclude, confidence interval, it can be used in various scenarios in businesses. So in essence, it provides a range of values around the sample estimate so that you can make informed decisions about the data that is calculated from a sample and make data-driven decisions. So next we look into how to determine the confidence interval for a mean using the t-distribution for small samples. So determining the confidence interval for a mean using t-distribution is useful when you are dealing with small samples. For example, when the sample size is less than 30 or when the population standard deviation is unknown. So this also involves various steps where you can calculate a confidence interval. So the first step is to gather data and calculate sample statistics. So in this, you have to collect your data and calculate the sample mean and sample standard deviation. Then the desired confidence level is calculated, which is, it is expressed often as a percentage, which can be 95% or 99%, which means in 95% you can have a 5% deviation in the accuracy of the sample, and in 99% you allow only 1% deviation. So this represents the probability that the confidence interval will contain the true population mean. Then in step 3, you find the degrees of freedom. So for a t-distribution, degrees of freedom is generally based on the sample size. So in this, the degrees of freedom is calculated as the total sample size minus 1. So the next is finding the critical value. The So the critical value associated with the desired confidence level and degrees of freedom is calculated using a statistical software such as SPSS or R. For example, for a 95% confidence with 20 degrees of freedom, the critical value might be approximately 2.093. So you can use a sample of 20 plus minus 2.093. Then you have to calculate the margin of error. So margin of error is the range within which the true population mean is likely to fall. So it is generally calculated using the formula E is equal to T into NS, where E is equal to the margin of error, T is the critical value from the T distribution, and S is the sample standard deviation, and N is the sample size. So this is how you calculate the margin of error in a characteristic. In a sample, sorry. Then you have to calculate the confidence interval. So now that you have a margin of error, you can calculate the confidence interval by adding and subtracting the margin of error from the sample mean. So this is calculated by the formula Ci is equal to X bar plus minus E, where X bar is the mean. So the confidence interval will have two values, a lower limit and upper limit. So these values represent the range within which you can be confident that the true population mean lies. So then we have to interpret the confidence confidence interval. So whatever statistics that you're carrying out, you have to use the confidence interval and apply it in the context of the business. For example, if you have calculated a 95% confidence interval for the average customer wait time and obtained 10.5 minutes, 13.2 minutes, so you can say that we are 95% confident that the true average customer wait time falls between 10.5 and 13.2 minutes. So in summary, when we are dealing with small samples or when the population standard deviation is unknown, a confidence interval for the mean can be calculated using the T distribution. So this interval provides a range of values within which the true population mean is likely to fall within a specified level of confidence. So next we look into how to determine the confidence interval for a proportion. So for calculating the confidence interval for a proportion, it involves estimating the range within which the true population proportion is likely to fall. So this is useful when we are dealing with categorical data or binary outcomes. So in this, the first step is to gather the data, wherein you collect your sample data, which consists of a binary variable. For example, success or failure, heads or tails. So that is the your data. So next you have to determine the desired confidence level. So here you specified the desired confidence level, often expressed as a percentage. For example, 95% or 99%. So this represents the probability that the confidence interval will contain the true population proportion. Then you have to calculate the sample proportion. So the sample proportion is calculated by dividing the number of successes by the total sample size. So then you have to find the critical, you have to multiply it. There is some error over here. Then you have to find the critical value. So for confidence intervals for proportion, you typically use the standard normal distribution, which is the Z distribution, instead of T distribution. So here you find out the critical value associated with the desired confidence level. So this value is found in a statistical table. For example, for a 95% confidence level, the critical value might be approximately 1.96. So this is derived from a statistical table. Then you have to calculate the margin of error. So margin of error is the range within the true population proportion is likely to fall. So it is calculated using the formula E is equal to Z into NP to the power NP into 1 minus P. So here E is the margin of error, Z is the critical value from the standard normal distribution, P is the sample proportion, and N is the sample size. The next step is to calculate the confidence interval. So now that you have the margin of error, the confidence interval for the proportion is calculated as Ci is equal to P minus E, comma P plus E. So again, the confidence interval will have two values, a lower limit and an upper limit. So these values represent the entire range within which you can be confident that the true population proportion lies. So this is how you calculate the confidence interval for a proportion. So now coming to the interpretation part. So you have to present your interpretation so that it can be viewed as a managerial decision-making process. So for example, if you have calculated a 95% confidence interval for the proportion of customers who are satisfied and obtained the values of 0.2, 0.72 and 0.88. So this can be interpreted as we are 95% confident that our true proportion of satisfied customer falls between 72% and 88%. So 72% is the lower range and 88% is the upper range. So in summary, determining the confidence interval for a proportion involves calculating the sample proportion, finding the critical value from the standard normal distribution, calculating the margin of error, and then constructing the confidence interval. So this interval provides a range of values within which the true population proportion is likely to reside within a specified level of confidence. So now next we look into how to determine the sample number required to obtain a confidence interval of a given size for a stated probability. So, to determine the sample size required to obtain a confidence interval of given size for a stated probability, you would have to calculate the desired levels of confidence, margin of error, and certain population parameters. So for example, how standard deviation or proportion can be calculated. Then, so this also involves a series of steps. So the first step is the definition of the parameters. So confidence level. So first step is always to specify the desired confidence level, typically 95% or 99%. Then you have to define the margin of error, so which represents the half width of the confidence interval. And then this is the maximum acceptable deviation from the true parameter value. Then step 2 is to identify the appropriate distribution, whether it's normal distribution or not. So for estimating population mean, you have to use the normal distribution. And then for estimating the population proportion, you have to use the standard normal distribution. Then you have to find the Z-score or T-score. So for the desired confidence level, you have to find the corresponding critical value from the chosen distribution. So use a standard normal distribution table or statistical software. Again, you can use SPSS, R. So it is your choice on which statistical software you are comfortable in. And then, for example, for a 95% confidence level, two-tailed test, the critical Z-score is 1.96, like we also looked into earlier. Then calculating the sample size formula. So the sample size formula varies depending on whether you are estimating a mean or for a proportion. So for estimating a mean, formula is again E square, Z square, and the square of the population standard deviation. So N is the required sample size, Z is the critical Z score, sigma is the population standard deviation, and E is the desired margin of error. And for estimating for a proportion, you have to use 2n, E square Z square into P into 1 minus P, where n is equal to required sample size, Z is the critical Z score, P is an estimate of population proportion, and E is the desired margin of error. So finally, you have to interpret the results. So, for example, if your calculated sample size is 385, you would need to collect data from at least 385 individuals to construct a confidence interval of the desired size for the stated probability. So, in summary, determining the sample size for a confidence interval involves specifying the confidence level and margin of error and population parameters, and then using the appropriate sample size formula for whether mean or for a population or for a proportion. So this calculation ensures that your confidence interval will have the desired size for a given level of confidence and precision. So that is how you interpret the results. So next we look into assessing the value to a business of using confidence intervals. So the use of confidence intervals is crucial to businesses across various domains because it provides a statistical interpretation of the scenario so that you can make data-driven decisions. So some of the use of using confidence intervals is, the first one is informed decision making. So the value is that confidence intervals, it provides decision makers with a range of plausible values for population parameters such as means or proportions. So this helps in making informed decisions by considering the uncertainty associated with the estimates. Then you have risk management. So businesses, they often face risk with respect to the financial forecast, revenue targets, market predictions, and product performance. So confidence intervals, they quantify this uncertainty. For example, in a portfolio, the confidence interval will quantify how much loss you're likely to make on any given bad day, or on a good day if the market goes by so and so percentage. So this helps in risk assessment and mitigation. Then precision in marketing and sales. So confidence intervals, for market research and sales forecasts helps the businesses to set realistic targets. They also allow marketing teams to assess the effectiveness of campaigns and promotions. In quality control and process improvement, the confidence interval help in monitoring and improving processes. They indicate whether the process is within specified quality limits. Then in financial analysis and investment, confidence intervals in financial analysis, they provide a range of potential outcomes for investments in budgeting. So they assist in assessing the risk associated with investment decisions. Customer satisfaction and loyalty. So again, a confidence interval for customer satisfaction surveys allows the businesses to get an idea of the customer sentiment with a certain degree of uncertainty, because you cannot be 100% sure about the customer sentiment. So it guides efforts to enhance customer experience and loyalty. Then again, human resources and workforce management. So the confidence intervals for employee turnover rates, they provide an idea of what is likely to be the attrition rate. For example, you would want to assess the attrition rate after appraisal or after the performance bonus. So how many employees are likely to stay and how many employees are likely to leave. So these help HR departments identify areas for improvement and make data-driven decisions. Then you have inventory management. Again, confidence intervals for demand forecasts. They guide inventory management by indicating the range of potential demand levels. So this reduces overstocking or stockouts. And then finally, in pharmaceutical research, confidence intervals for clinical trials outcomes provides insights into the effectiveness of new drugs and potential side effects, assisting in regulatory decisions. So to conclude, confidence intervals are a valuable tool for businesses across different sectors. So they provide a structured approach to dealing with uncertainty in decision making, managing risks, setting realistic targets, and improving processes. So by using confidence level effectively, businesses can enhance their overall performance and competitiveness and ability to adapt to changing market conditions. So that is all for the time being. In case if you have any questions, you can let me know.
That's great. Thank you, Sanjay.
Thank you.
Thank you very much.